The following is a concept demonstration. Water enters the barrel at normal speed, but when confronted with the pressure of the jets, it accelerates. Water enters from the stream. Centrifugal energy is processed. Then the water is released back into the stream. When compacted into a smaller system, which generates usable power that can...
See how huge it is?
Yeah.
The
Wow.
curve of that,
Yeah.
that's equivalent to the curve of that rotor right there.
Okay.
And then I have my generator. Feel this with your finger.
Yeah, that spins pretty easy.
Yeah. Well, then what we do is we pressurize the tank. It runs the motor. It goes in here, goes back through here, and blows in here. So it's just waiting for the tank to be put, the top piece put on.
And the idea that pressurizing the tank would actually reduce the amount of power consumed by the pump motor is a bit counterintuitive. You know, in standard physical terms, how could merely pressurizing this compartment reduce the amount of energy it takes to feed the rotor? This is an effect that Geoffrey has tested, and it definitely
works. Because look at it from a logic point of view. When the air goes in here, there's 3 steps in turning this thing on. And when you turn the thing on, you fill it with water, and the water's already in there. And then you go ahead and you get the pump going. So then all the stuff starts to come flying out of here. It's instantaneous when this thing goes on. I'll show it to you on a video up there. And then after it goes instantaneous and speeds up and everything, then what we do is we pump it with air. And as the air pushes down on the water, do you even think it's like electricity? You think the air is going to go through those little nozzles at high speed?
which are occupied by high-speed water coming out.
Not in a million years. They're going to go through the 3-inch nozzle. They're going to go, whoa, we're going to go back down and help the pump. And then it pushes that, and then the pump goes, wait a minute, I don't have to work as hard. And then the more air you push in, more. So what we have is, right now the pump will make 100 PSI on here, right? Then what we do is we add 100, that means we eliminate the pump. Then when we add 125, we're 25% over the pump. So that's 25% free energy. Then if we add 25 more, that's why we need a steel tank. We can add as much pressure we want. The more pressure we add, the faster this goes, blah, blah, blah. And then this is a generator pushing. You just hook up all your lights. Or whatever
You built one of these before, haven't you?
Oh, I built them. I got one here, I got one here, I got one here. Here, feel this.
This is one that's decades old, right? There. Or is that the one is that the old one?
That's one of the old ones, yeah.
This one was just built in the last year.
Yeah. You know. Do we want to run it? You want to see it run?
Sure.
You know what? Since it's not raining out, do one line.
Is there any way to turn off the lights?
No, just go. I forgot to put the things on. You can pull it off. Yeah.
What did you mean to put?
The top plates.
Well, we got a good shot of it anyway.
Yeah.
That's pretty. Yeah.
Yep. See how instant it happens?
And it definitely
Let me wipe
accelerates.
this
So
off.
as it goes faster, there's like the centrifugal effect makes it go faster yet. You know, to a certain range.
Yeah, let's go get the top plate.
Now, conversely, if you put a mechanical load on it that slows it down, then it would tend to, at beyond a certain point, this is where I need to understand the dynamics, beyond it would tend to slow down further unless you, sort of like the throttle of a car. You know, if a car didn't have a fuel injection system or a carburetor that could adjust the amount of fuel going in to the amount of load you're trying to put on your internal combustion engine, your car would just stall, and in fact it does if you don't operate properly. So this is similar here. When you want to draw, when you start to draw mechanical energy off, you know, off the shaft, you're going to tend to slow down the turbine, which is going to reduce the amount of centrifugal energy gain you're getting, which is a negative feedback, right? So that's why that draft patent application includes a system that basically it detects when it's starting to slow down, probably because you're putting a load on it, and then it makes adjustments that increase the amount of thrust here. You know, sort of like the original regulators on the original steam engine. You know, the steam engine was impractical. It would run away with itself until someone came up with a governor. So anyway, so the thing that this requires a governor that sort of like more like the internal combustion engine increases the thrust at the nozzle to match increased load on the shaft, and that's how you can control its speed and draw more mechanical power off of it and not have it just stall.
That's pretty good. We haven't run this in 1 year, have we?
No.
And we haven't run it with the new things. I could tell immediately how quick that was. Those things are working beautiful. Let me get my camera out.
Oh, the new nozzles?
Yeah.
Oh, that's right.
No, not the new nozzles.
Oh, yeah.
I haven't even tested this.
The veins around it. Yeah. Initially, we didn't have the veins here.
Here, Sterling, get by that so I can take a picture of you and Doug.
Operate the mechanical switch here.
I got it going.
Ready to go?
Yep. Always have more power. Holy cow. Hear it increasing?
Yeah. See,
Yeah.
Because the centrifugal force increases the pressure. Actually, it wants to run away with it.
I know.
It's still speeding up.
See, it's still speeding up.
Equilibrated now.
Yeah, hit it off so we don't burn the lights.
So, you know, the dynamics of this thing would be a great project for some engineering graduate student to study, right? And work out all the physical processes that are going here and how you would engineer it, you know, to regulate it.
I have those blue things filled with data that I did for 5 to 8 years while I tested it. Now you picture that going at 500 RPMs with the 2 dual generators. All we need is a tank here. We lift this up, drop it in, put the tank, and we have an open.
Yeah, this is such a large diameter that it generates an adequate surplus of energy without being pressurized. Whereas this one, according to Geoffrey's design, needs to be pressurized to add an additional amount of advantage.
Oh crap! We didn't put the light bulbs on.
Oh, you had the generator. Well, good thing we didn't. By the way, there's high voltage here. We should have.
Oh yeah. Oh yeah.
That would have actually.
Oh, Doug already has found that out himself.
I don't know. It's several hundred.
That's why I got to have this
several
thing
hundred
down.
volts were appearing right there. Yeah, we should have mentioned.
Yeah, we forgot to tell you that. We know what it is. We killed Sterling in EnergyBat labs by accident.
Well, it's also. I hope you didn't have any coils shorted because they might be nicely burned out now.
Nah, no, these were all just pretty much like that. Yeah. But then feel this, Sterling. I mean, feel it with your finger.
Yeah, it spins easy.
Yeah. But you saw how it builds up the pressure and the speed and wants to keep going. I can make this thing self-destruct by doing it on the vacuum side. I can pull a vacuum, it'll do the same thing. And that's what we want to do, is build one, put it out in the middle of a parking lot, and just watch it blow itself to kingdom come.
Yeah.
Without a governor.
With a very dense fluid like mercury, you can see how you might get quite a lot of torque out of a very small device.
Why it's so foamy and white is because I put antifreeze agent thing in here because I had to have them inside. I didn't want them to freeze. I didn't want the pumps to freeze.
So that's why it's foamy.
So that's pretty good, man. We just popped this thing on, works instantly. That's great. I'm excited because, Doug, you gotta admit, this thing works beautifully. And see, there's a shroud that actually is supposed to go on there. I can show you a million different ways. And this is only, look at this. But then this is only a 1/4 inch tube going in here.
Yeah, the next interesting test will be to seal it.
We're going to seal it,
pressurize it,
and then pump the air
and see if and prove your previous observation, replicate your previous observation that the power draw on the pump will actually drop as you pressurize this.
Yeah. Okay, then. These are the original CEACU things.
That's the machine that's downstairs.
Well, this is the wood one.
Oh, that's the prototype.
Yeah. See, remember, I can make to show you how pathetically simple this was. I made the whole thing out of wood. So if you make turbine out of wood, what do you think will happen when you put steel to it? There's the generator head hooked up there. See, I told you it was 2 pulleys, but we have the angle drive, so it'll lay there and everything. I've got like 2,000 hours worth of, that's my hydrogen tank thing I was working on. 2,000 hours. Oh, there goes the pressurized tank, right there. Running the generator, going up here when I first got the pulley. I mean, not the pulley, rotating union and everything. And there goes the system. There go the pumps I used. And there it is set up.
That's in Nancy's backyard?
This is all in Nancy's backyard.
Just up the street here,
yeah.
What one was this about? What year?
It was all in the 80s. Yeah. And then I was making the trash can one and the spoke one for testing. That was my testing tank. Any new one I put on there, I could test it, hit that on, boom. And then that was the big testing tank that I could have the water go through there. And then once the pump got going, then it would circulatory up, and then I'd shut it off, and it would suck a vacuum, and it would go ahead and do the thing without the pump running. And there goes, I made this so that you could disassemble it. So I'd take it out to Washington. And then it was showing how you can make it out of a trash can. And it's a generator unit there. That's how compact the whole thing would be if I get the right pressure tank. And again, more of the shots. The books just keep going on and on and on. And that's the disassembly of the whole thing. Then I built the big tank.
Is this the test? Do you have any pictures of the test out west in the mountain, on the mountain stream?
Oh yeah, but they're in the computer things. That's up on the website.
That's right.
Yeah. So then this was the first test, and it was so powerful on this thing, and then the neighbors started bitching and moaning, so I'd take it down pretty much after I put it up.
The following is a concept demonstration. Water enters the barrel at normal speed, but when confronted with the pressure of the jets, it accelerates. Water enters from the stream, which generates usable power that can...
See how
Okay.
huge it is?
Yeah.
The
Wow.
curve of that,
Yeah.
that's equivalent to the curve of that rotor right there.
Okay.
And then I have my generator. Feel this with your finger.
Yeah, that spins pretty easy.
Yeah. Well, then what we do is we pressurize the tank. It runs the motor. It goes in.
Centrifugal energy is processed. Then the water is released back into the stream. When compacted into a smaller system,